Now, if you were to look at a periodic table, you'll find a number there besides the atomic number in the simplest forms of periodic table. Besides the atomic number, for example, for magnesium, the atomic number is 12. You'll see another number that has a decimal, in this case, 24.31. In some periodic tables, it might show up as 24.305. That number is called the atomic number. It's actually a unitless number. Okay? That's just the numerical value of the average mass of the atoms in a naturally occurring sample of an element. So we say 24.31 or 24.305 is the atomic weight of magnesium. That's actually a relative number. Okay? That doesn't have any unit. Okay? So, and in fact, that's also the average mass in a naturally occurring sample of magnesium. There isn't a single magnesium atom that has that mass. Okay? And the reason that's the number that you'll see in a typical periodic table is generally when we're working in the lab, we'll be dealing with a naturally occurring sample of magnesium, the kind of magnesium you'll find in nature. We don't have isotopically pure samples. Right? So let me just show you a periodic table where you might see that here, for example, on webelements.com. You have magnesium right here, 24.305. That number, that's the atomic weight of magnesium. That means if you were to have a naturally occurring sample of magnesium, you have some magnesium 24, magnesium 26, magnesium 25. If we average out the masses of the atoms in that sample, it comes out to 24.305 atomic mass units. Okay, so magnesium 24, if you remember, what would be its mass? 24.0. And then magnesium 25 will have a mass of 25.0. Magnesium 26 would have a mass of 26.0. None of them has a mass of 24.305. So, how do you actually calculate these atomic weights? You can figure it out, although it's already given to you, but if you're given a hypothetical, for example, you might be given the isotopic abundance. So, let's figure it out for magnesium. Let's verify that, in fact, it's 24.31. Okay, so you look up the isotopic abundance and the masses of the individual isotopes. And the average mass will just be calculated using this formula. You multiply each of the isotopic mass by its relative abundance, and then you just add them all up. So let's look at an example here. If you look up magnesium, okay, 24, you'll find it's 79% of the magnesium you'll find in nature. Again, you can go to webelements.com to do that. Let's see. Isotopes. So here's the natural abundance. Magnesium 24, magnesium 25, and magnesium 26. Okay, so this is where I got those numbers from. So let's just say 79%, and it's 24.99 atomic mass unit for each one, or that's 24.0 if you want to do one decimal place, right? And magnesium 25, 10% of the atoms will be magnesium 25. Each one would have a mass of 25.0. So if you want an extra decimal place, it would be 24.99 if you looked it up. Okay, magnesium 26 is 11%. So how do I get the average? Well, let's imagine you have 100 of these, right? So you add up all the masses, right? So average mass, total mass, total number of atoms, right? That's how you can calculate the average, right? You add up everything, divide by how many you have of each. So I'm going to say then, okay, my 24.99, how many of those do I have? I have 79 of those, right? And my 23.99. And then 24.99, how many do I have of those? I have 10 of those, right? I have 79 of these out of 100, right? Plus my 25.98, how many of that do I have? 11, right? So you add all of those, divide by the total number of atoms, which would be 100 if I had 100 atoms, right? So you can see, if we can simplify this, you can see this is 79 times that, right? So that's 79 times 23.99. That's the mass of the magnesium 24 isotope, plus 10 times 24.99. That's the mass of the magnesium 25 isotope, plus 11 times 25.98. That's the mass of the magnesium 26 isotopes, divided by 100. Okay? You can work it out now if you want to, but I want to work this out differently so that you can see where the formula comes from. 79 over 100 times 23.99. I can break it up, right? And I can say this is 10 over 100 times 24.99 plus 11 over 100 times 25.98. Okay? In other words, what did we do here? We multiplied, this is the mass of magnesium 24 by the abundance, okay? Relative abundance, you might say, or the percentage of magnesium 24. And if we did all of these calculations, you'll find that you're going to get 24.31. Let's go ahead and do that with a calculator. So I'm going to say 79 over 100 is 0.79, right? So 0.79 times 23.99 plus 10 over 100 is 0.1 times 24.99 plus 11 over 100 is 0.11 times 25.98. That gives you 24.31. Okay. So that is the average mass of atoms, magnesium atoms, in a naturally occurring sample of magnesium.